My name is Bhaskarchand Gautam, and at the moment I'm working in Technical University of Eindhoven with the supervision of Katrina Esteves. I'm at a postdoc position. The material can be swell and shrink depending upon the stimulus you provide. It can be a magnet, it can be light, it can be a temperature, operation, and so on. And we are hoping that someday we can implant this activator to the actual bionic devices, so to help the human's betterment. This is the overall goal of this project. And then we have a different several packages who work on different topics. So some people doing 3D printing, some people doing chemistry, some people are doing polymer and simulation theory and so on. And we club everything together to give a proper results during this for this project. So make sure that we have at least some kind of responsive material which can be used for as a bionic muscles. I work on work package 4. This package deals with hydrogel synthesis with several nanocomposite material. So I use cellulose nanocrystals and mix them with the in the thermoresponsive hydrogel, and then coat it on a flat surface. At the moment I'm using glass, and later I'm gonna do the metal as well, and 3D surface as well, and gonna see how this material behaves when they are grafted or they are coated on the surface and when you apply the stimulus. So at the moment it's the project also in a preliminary stage. So somehow I find a way to make a cellular nanocrystals, low-rate nanofiber, gonna crush them and infuse inside the hydrogel. So the hydrogel not only have the stiffness but also can give more thermoresponsive behavior when you apply the external potential. In my case, is temperature. This is really challenging project, by the way. So I'm kind of polymer chemist. I know some some chemistry as well, organic chemistry, but here I gain some knowledge of electrospinning and new setup, new experiments, and gain a lot of experience in biological, how the things actually works. And with the help of other colleagues, I also get information of how stimulation, how simulation, and as a theory works. Back in the days we only do the synthesis, we do the material purification, material synthesis, but we don't care about how actually simulation can help us to make to just convince, let's say, reviewer or the normal people to that what we are doing actually have a potential to get an upscale, and or maybe a potential to be let's say to go to the industrial level. But when you're doing simulation studies and you also have interaction with the biological people who can say that okay, your material is actually biologically quite suitable for us, so then you get a lot of confidence. So answering your question is like, I get to learn lots of things now, not only the organic synthesis, polymer chemistry, coating, 3D printing, electrospinning, and biology, and a bit of simulation ideas. I think I gain a lot of experience, and I hopeful I can get up in a good research and development sector. I hope so.